To calculate the conduit fill for a service with different size conductors, the first step is to determine the area of each individual conductor. The formula for the area of a circle, which represents the cross-sectional area of a conductor, is area equals pi times r squared, where r is the radius of the conductor. The radius is half of the diameter. Once the area of each conductor has been calculated, the next step is to add the areas of all the conductors together. This sum represents the total area occupied by the conductors within the conduit. Finally, to determine if the conductors can be installed in a conduit, compare the total area occupied by the conductors with the allowable fill area of the conduit. The allowable fill area is determined by the type of conduit and the number of conductors. The National Electrical Code, or NEC, specifies the maximum allowable fill for different types of conduits and wiring methods. The NEC provides tables that list the dimensions and fill percentages for various conduit sizes. The allowable fill percentage depends on the number of conductors in the conduit. For example, for 3 or more conductors, the maximum fill percentage is typically 40%. To determine the allowable fill area, multiply the cross-sectional area of the conduit by the allowable fill percentage. If the total area of the conductors is less than or equal to the allowable fill area of the conduit, the conductors can be installed in that conduit. If the total area of the conductors exceeds the allowable fill area, a larger conduit size must be selected. In the example provided, there is a 4/0 aluminum conductor with a diameter of 0.6875 inches and a 2/0 aluminum conductor with a diameter of 0.5625 inches. To calculate the area of the 4/0 aluminum conductor, first find the radius by dividing the diameter by 2, which results in a radius of 0.34375 inches. Then square the radius, resulting in 0.1181. Finally, multiply by pi, or approximately 3.14, to get the area of 0.3710349 square inches. To calculate the area of the 2/0 aluminum conductor, first find the radius by dividing the diameter by 2, which results in a radius of 0.28125 inches. Then square the radius, resulting in 0.791,015. Finally, multiply by pi, or approximately 3.14, to get the area of 0.2,483,787 square inches. To find the total fill, add the area of the 4/0 aluminum conductor, which is 0.3,710,349 square inches, to the area of the 2/0 aluminum conductor, which is 0.2,483,787 square inches, for a total of 0.6,194,136 square inches. This total fill of 0.6,194,136 square inches must be less than the allowable fill for the selected conduit size. To select the appropriate conduit size, refer to the NEC tables for conduit dimensions and allowable fill percentages. Look up the cross-sectional area of different conduit sizes and multiply by the allowable fill percentage, typically 40% for 3 or more conductors. Choose a conduit size where the allowable fill area is greater than or equal to the total conductor area of 0.6,194,136 square inches. For Schedule 80 conduit, the internal diameter is smaller than Schedule 40 conduit, so be sure to use the dimensions for Schedule 80 when determining the cross-sectional area. The NEC specifies requirements for conductor fill in Chapter 9. In particular, Table 1 provides the percentage of cross-section of conduit and tubing for conductors. Note 1 states that combinations of conductors of different sizes are permitted. The percentage fill is based on the actual dimensions of the conductors. Chapter 9, Note 9 states that a conductor's area includes insulation. When calculating conduit fill, it's important to consider several factors. Firstly, always use the correct dimensions for the specific type of conduit being used. Schedule 80 conduit has a smaller inside diameter than Schedule 40 conduit of the same nominal size. Secondly, ensure that the conductors are properly sized for the intended load and application. Refer to NEC tables for conductor and capacity ratings and adjust for ambient temperature and the number of conductors in a raceway. Thirdly, use the correct fill percentage based on the number of conductors in the conduit. The NEC specifies different fill percentages for different numbers of conductors. For example, for one conductor, the maximum fill percentage is 53%. For two conductors, the maximum fill percentage is 31%, and for three or more conductors, the maximum fill percentage is 40%. Fourthly, when calculating the area of conductors with irregularly shaped insulation, such as those with ridges or grooves, use the dimensions provided by the manufacturer. If the manufacturer's dimensions are not available, measure the conductor's diameter with a caliper or micrometer. Fifthly, consider the effects of conduit bending and pulling tension on conductor insulation. Avoid sharp bends and excessive pulling force, as this can damage the insulation and reduce the conductor's ampacity. Use pulling lubricants to reduce friction and tension during installation. Sixthly, when installing conductors and underground conduits, consider the effects of moisture and corrosion. Use conductors with moisture-resistant insulation and seal the conduit ends to prevent water from entering. Consider using corrosion-resistant conduit materials such as PVC or fiberglass. Seventhly, always follow the NEC guidelines and local electrical codes when installing conductors and conduits. These codes are designed to ensure the safety and reliability of electrical systems. Eighthly, it is a good practice to leave some extra space in the conduit for future expansion or modifications. This can be achieved by using a slightly larger conduit size than is strictly required by the fill calculations. However, do not exceed the maximum fill percentages specified in the NEC. Ninthly, ensure that all conductors are properly identified and labeled. This can be done by using color-coded conductors or by labeling the conductors with wire markers. Proper identification and labeling can help prevent confusion and errors during maintenance and troubleshooting. Tenthly, before installing any conductors in a conduit, inspect the conduit for any damage or obstructions. Remove any debris or sharp edges that could damage the conductor insulation. Ensure that the conduit is properly supported and secured. The selection of the correct conduit size is crucial for ensuring the safe and efficient operation of electrical systems. Undersized conduits can lead to overheating, insulation damage, and even electrical fires. Oversized conduits can increase material costs and make installation more difficult. By carefully calculating the conduit fill and following the NEC guidelines, one can select the appropriate conduit size for any application. Consider a scenario with multiple conductor sizes. Firstly, calculate the area of each conductor individually using the formula area equals pi times r squared, where r is the radius of the conductor. For example, consider a conduit containing 1 4/0 AWG conductor, 2 2/0 AWG conductors, and 3 number 6 AWG conductors. Look up the diameters of each conductor in the NEC or a conductor manufacturer's catalog. Suppose the 4/0 AWG conductor has a diameter of 0.6875 inches, the 2/0 AWG conductor has a diameter of 0.5625 inches, and the number 6 AWG conductor has a diameter of 0.2043 inches. Secondly, calculate the radius of each conductor by dividing the diameter by 2. The radius of the 4/0 AWG conductor is 0.34375 inches. The radius of the 2/0 AWG conductor is 0.28125 inches, and the radius of the number 6 AWG conductor is 0.10215 inches. Thirdly, calculate the area of each conductor using the formula area equals pi times r squared. The area of the 4/0 AWG conductor is approximately 3.14 times 0.34375 squared, which equals 0.371 square inches. The area of each 2/0 AWG conductor is approximately 3.14 times 0.28125 125 squared, which equals 0.248 square inches. The area of each number 6 AWG conductor is approximately 3.14 times 0.10,215 squared, which equals 0.33 square inches. Fourthly, calculate the total area of each conductor size by multiplying the area of each conductor by the number of conductors of that size. The total area of the 4/0 AWG conductor is 1 times 0.371 square inches, which equals 0.371 square inches. The total area of the 2/0 AWG conductors is 2 times 0.248 square inches, which equals 0.496 square inches. The total area of the number 6 AWG conductors is 3 times 0.33 square inches, which equals 0.99 square inches. Fifthly, calculate the total area of all conductors by adding the total area of each conductor size. The total area of all conductors is 0.371 plus 0.496 plus 0.99, which equals 0.966 square inches. Sixthly, determine the appropriate conduit size based on the total conductor area and the allowable fill percentage. Consult the NEC tables for conduit dimensions and allowable fill percentages. For example, if using Schedule 40 PVC conduit and the allowable fill percentage is 40%, find a conduit size that has a usable area of at least 0.966 square inches. The NEC tables show that a 1/4 inch Schedule 40 PVC conduit has an inside area of 1.33 square inches. Since 40% of 1.33 square inches is 0.532 square inches, which is less than 0.966 square inches, a 1/4 inch conduit is not large enough. The NEC tables also show that a 1/2 inch Schedule 40 PVC conduit has an inside area of 1.70 square inches. Since 40% of 1.70 square inches is 0.68 square inches, which is still less than 0.966 square inches, a 1/2 inch conduit is not large enough. The NEC tables also show that a 2-inch Schedule 40 PVC conduit has an inside area of 3.36 square inches. Since 40% of 3.36 square inches is 1.344 square inches, which is greater than 0.966 square inches, a 2-inch conduit is large enough. Therefore, a 2-inch Schedule 40 PVC conduit would be the appropriate size for this application. Remember to always consult the latest edition of the NEC and local electrical codes for the most accurate and up-to-date information. Consider directing factors for conductor ampacity due to the number of current carrying conductors in the conduit. The NEC specifies directing factors that must be applied when there are more than 3 current carrying conductors in a raceway. These directing factors reduce the allowable ampacity of the conductors to prevent overheating. Determine the number of current carrying conductors in the conduit. In this example, there are 6 current carrying conductors, 1 4/0 AWG, 2 2/0 AWG, and 3 number 6 AWG. Consult the NEC tables for the applicable directing factors. The directing factors depend on the number of current carrying conductors. For example, if there are 4 to 6 current carrying conductors, the directing factor is 80%. Multiply the allowable ampacity of each conductor by the directing factor to determine the direct ampacity. The allowable ampacity of each conductor can be found in the NEC tables. For example, if the 4/0 AWG conductor has an allowable ampacity of 230 amps, the derated ampacity is 230 amps times 80%, which equals 184 amps. Ensure that the derated ampacity of each conductor is sufficient for the intended load. If the derated ampacity is not sufficient, increase the conductor size or reduce the load. Consider voltage drop when selecting conductor sizes. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Calculate the voltage drop for each conductor size using the appropriate formula. The voltage drop formula depends on the conductor material, length, current, and voltage. Consult the NEC or an electrical engineering handbook for the voltage drop formulas. Ensure that the voltage drop does not exceed the maximum allowable voltage drop specified in the NEC or local electrical codes. The NEC recommends that the voltage drop should not exceed 3% for branch circuits and 5% for feeders. If the voltage drop exceeds the maximum allowable voltage drop, increase the conductor size or reduce the length of the circuit. When calculating conduit fill and selecting conductor sizes, it is important to use accurate and reliable information. Consult the latest edition of the NEC, conductor manufacturers' catalogs, and electrical engineering handbooks for the most up-to-date information. Use calibrated measuring instruments to accurately measure conductor diameters and conduit dimensions. Double-check all calculations to ensure accuracy. By following these guidelines, one can ensure that the conduit fill calculations and conductor size selections are correct and that the electrical system is safe and reliable. For complex installations or when in doubt, consult with a qualified electrical engineer or electrician. They can provide expert advice and ensure that the installation meets all applicable codes and standards. They can also perform load calculations, voltage drop calculations, and other engineering analyses to optimize the design of the electrical system. In summary, calculating conduit fill with different size conductors requires careful attention to detail and a thorough understanding of the NEC and other applicable codes and standards. By following the steps outlined above and consulting with qualified professionals when necessary, one can ensure that the electrical system is safe, reliable, and efficient. Remember to always prioritize safety when working with electricity. Wear appropriate personal protective equipment such as safety glasses and gloves. To energize circuits before working on them. Follow lockout/tagout procedures to prevent accidental energization. If you are not qualified to work on electrical systems, hire a licensed electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent injury or death. Keep in mind that this is not a complete guide for electrical engineering or calculation. It is important to consult a professional for complete design.